said a while ago that I will be having a pre-recorded video with regards to the continuation of our topic for this day. So I've already done discussing the kinetic molecular theory and also with regards to the liquid. And so now let's proceed to the solid part. As we all know that our main topic for this day is to know the description pertaining to the kinetic molecular theory based on the solid and the liquid. Okay, since I've already done discussing liquid, let's go on to the solid. So as we all know, solid as a rock. Solid is, when we say rock, it is hard. It is a description of solid, something that is hard, as I've said, unyielding, with a definite shape and definite volume. Comparing to liquid, if liquid has a definite volume but hence does not have a definite shape, but regardless with if you put the liquid into a container, you will the liquid itself will be having a shape. Comparing to solid, it has both definite to volume and both definite to shape. Many things other than rocks are solids. Of course, not only rocks, kasi all the thing, not even the thing, all the substances, or let's say a thing to be exact, that is hard, that has its compactability, that has that is compressed with regardless to its particles, is part of a solid. So in fact, solids are more common than liquids. This diagram shows the particles of gas, liquid, and solid. So that's why I've said a while ago that temperature and pressure is considering as a part of the motion of the three states of matter. Kasi nandun talaga sila. It explains the motion or the movement in the particle of the three states. So let's take a look with the illustration below. So as you can see, when we say in a gaseous state, we have decrease in temperature but increase in pressure. While in the liquid state, it also decrease in the sense of temperature and increase in the particle. While in the solid state, when we say solid state, kasi it is very different with regards to the movement or the motion of the both state, kasi as I've already discussed that one kasi in solid part there is no space. The particle is compact together, very close together. So it makes sense that in the temperature, if we explain the temperature and pressure of the solid state, it increase. Okay, it increase. So comparing to the both state, like gas and liquid, both gas and liquid has decreased temperature and increased pressure pertaining to the particles. While in the solid state, it is both increase in temperature and increase in pressure. Okay, so if you have a question clarification with this slide, you can actually basically ask me personal message in the messenger, or you can ask it in our GC. So let's move forward. So this explains what is solid. The same with the liquid a while ago. I already explained what is liquid, what is in the particle of liquids. Let's continue that in the solid part. So solid particles are tightly packed and close together, compact. Only the movement of the solid, it can be represented by the means of vibration. I already discussed that a while ago, that we can definitely see that the particle of the solid can move in the sense or in the presence of vibration. Nagba-vibrate sila. That's why, bakit sila nagba-vibrate? Sa dikit-dikit, walang space, there's no space, and the attraction and the forces of the both particles is very high. Malakas talaga, or strong. That's why it vibrates to each other. Particles do move but not very much. That's why I've said a while ago, they can be moved and you can see it by the vibration. Definite shape and definite volume, because particles are packed closely and do not move. I've already discussed that. Most solids are crystals. Yes. Crystals are made of unit cells, repeating patterns. So that's why solid, part of the type of a solid is a crystalline lattice. The shape of crystal reflects the arrangement of the particle within the solid. Okay, let's go more further about the discussion of the type or kind of a solid. So in this part, it is basically the description of a solid. Okay, let's move forward. So before we will go on to the type of a solid, let's of course discuss the same with the liquid, because liquid I've already discussed also the description pertaining to kinetic molecular theory. So let's go now to the solid state. Of course, the same with the liquid, solid state has also a kinetic molecular theory description. So according to the kinetic theory, the motion of solid particles can be described as lower kinetic energy, not lost energy, but lower lang. Ha? Please remember that one. Not lost, but lower. Only lower. Mababa lang. Kinetic energy, less motion, yes, because of the compactability of the both of the particles. The closer together or the fixed position of the particle, that's why it's less motion. More packed particles and higher intermolecular forces, or IMF. Yes, it has an higher intermolecular forces than the liquid itself. As I've said, all of the state has an intermolecular forces. Why? Because kinetic molecular theory can be possible by the means of intermolecular forces, or the attraction between the kinetic energy of the individual particles. Okay, let's move. Intermolecular forces between the particles are therefore much more effective in solids. Please take note with that. This hold particles of the solid in relatively fixed position with only vibrational movement. I've already discussed that. Very concise and in a simplest form of explanation. Solids are more ordered than liquid and gases. Okay. Why? Because there is a fixed position pertaining on the arrangement of the particle in the solid. Okay, always remember that it is more ordered than the liquid and the gas. Why? Because solid has its fixed position pertaining to the arrangement of the particle. Okay, let's move to another slide. So now, let's discuss the properties of the solid. I've already discussed the properties of the liquid. Of course, the same with the properties of the solid. Solid has definite shape and volume. We've already know that one. Solid maintain a definite volume without a container. Volume is constant due to the closely packed particles. Meaning to say, there is no need of container pertaining to if you want to know the volume of the solid. Because it is hard. It has also its own substance, its own shape than the liquid. Kasi liquid will depends on the container itself, but the solid not. You can eventually know or describe the description of a solid itself. If it is, what is the shape of the solid? If it is circle, the square, like that. So you can eventually know, or you can eventually describe the shape of a solid. Okay, as I've said a while ago, in pertaining to the fluid, of course, as we all know, solid is not a fluid itself, so it is non-fluid, meaning to say the particles of the solid itself can't flow. It can't have a movement nga, di ba? There is a movement itself, there is a motion, hindi mawawala, but by its own position, by the particle of the position of by the position of the particle itself, kung saan siya nakatayo or kung saan siya ang lugar ng particle na yun, diyan lang siya nagmo-move. And how can you determine the movement? By the vibration. The more vibrates of the particle, the strongest the compactability of the both particle. So that is the explanation between that. So non-fluid, if we compare it to liquid, which is fluid. Okay? Definite melting point. The temperature at which the kinetic energy of the particles are able to overcome the attraction or the attractive forces holding them together in fixed position. which is crystalline only. Okay, in this area of statement, definite melting point, yes. Some of the solid, not only some, but most of the time, most of the solid has its process like called melting point. You can melt a certain solid, like for example the metal. Metal, you can melt metal. That's why if you melt a metal itself, it will bring a liquid state. So all the solid state can be melt or can be a liquid in the process which is named by melting point. That's why it's called, it has a definite melting point with pertaining to solid. Pwede mo matunaw, pwede siya ma-melt, yon. Okay? Let's go to the high density. Solid are packed more closely than that of a liquid or gas. So, with regards to the density itself, it is more, so meaning to say, as I've said, more dense, see, solid. So, if solid is a more dense, of course, liquid is less dense than solid. So, that explains the high density of the property of a solid. Next is incompressible. Okay. Particles are packed so close together there is virtually no space between them. Incompressible, compressible ito siya ha. I have a typo in here. Compressible. Compressible, see particles of the solid. Why? Because it is packed so close together and there is virtually no space between them. Again, it is typo. It is compressible. Okay? Next, we have slow diffusion. So, pertaining with the diffusion part of the solid, much slower than liquid due to the high intermolecular forces between particles. Always remember that in diffusion, it has a higher part than that the diffusion takes place in the liquid. Why? Always remember that there is a higher intermolecular, or when we say higher intermolecular forces, it is pertaining to the solid. So in this part, you can identify agad easily that solid is a slow diffusion, has a slow diffusion. Okay? So now, let's proceed to the next slide. So let's go now to explain the type of a solid. As I've said, crystalline is one of the type of a solid. Classification of a crystals by arrangement and shape. So, as we all know that we can classify a certain crystalline solid by the means of its arrangement and shape. Crystal lattice define the total 3D array of points that describe the arrangement of the particles or a collection of unit cells. The smallest portion of crystal lattice that reveals the 3D pattern of the entire lattice is the unit cell. So, meaning to say, when we say crystalline solid or crystal lattice, it will focus on it will describe on the arrangement of the particles. If the arrangement of the particle shows that or reveals the 3D pattern, the entire crystal itself is a unit cell. Okay? Always remember that one. That it will depends on the arrangement of the particle. Okay? Let's move. Next type of a solid is amorphous solid. Amorphous solid is a rubber, glass, plastics, and synthetic fibers are called amorphous solids. So as you can see, this is actually a representation pertaining to a crystal, to a glass, and of course a gas. Okay? So this is kind of a representation only. So aside from amorphous, let me explain it further. Amorphous comes from the Greek for without a shape. So unlike crystals that has a shape, so because we all know crystal is more like a little or tiny particles or tiny circle to be exact. Not in a sense the perfect circle, but we can describe it as a circle, but not in a perfect circle. Yun yung we can define the shape of the crystals. But in amorphous, without a shape. Okay, take note with that. do not have a regular, natural shape, as I've said, but instead take on whatever shape imposed on them. So particle arrangement is not uniform. They are arranged randomly, like particles of a liquid. Examples of amorphous solid is glass and plastics. Okay, that is a good example, to be exact. Amorphous solid are prepared by rapid cooling of thin film materials. That's why I've said. That's why in the statement that it has no regular or natural shape, kasi it will depend. Sorry, it will depend. It will depend on the arrangement of the particle. Okay, if it is the arrangement of the particle of it is not uniform also, but um but they can arrange it randomly, like for example the particle of liquid. So that's why the examples for amorphous are the glass and the plastic. So as we all know that glass, there are different shape between the glass, diba? So that's why in the statement, take on whatever shape imposed on them. So there are different shape pertaining to this kind of solid, diba? Amorphous solid glasses, there are different shape of glasses. There are circle, square, rectangle, even triangle will be. Kasi it's depend on the person who will create a solid itself. It depend on the creation, or it depend on the imposement of what the shape would be. So that is amorphous solid. Okay, let's move. So this is the examples of molecularly, meaning to say the particles between the amorphous and crystalline. So this one. Siguro I will be discussing the deeper in the particles in the later part of the semester, or later part of this subject. Yan. So as you can see, it's very differ. Amorphous has a lot of particles than crystalline. And amorphous, you cannot identify the shape of it. But in the crystalline, it's like an organized particle. Okay, you know that? Do you get me about this one? If you literally go on with the particle itself, as you can see the patterns, it's more like that crystalline is having a clean pattern, while in an amorphous solid, it has a much more hard to explain about the pattern of it. Okay, let's move. So these are the changes of the state. So ito na lang, this can sum up everything that I've been discussing. So possible changes of the state. So as I said a while ago, that it is very easy. Sorry with that. It is very easy to identify the changes of the state, kasi you will be going back to basic. Once you've already know the three states of matter, you can eventually know the changes of state. Babalik ka lang sa tatlo eh. Coming from what? Coming from the result of the solid, liquid, and gas, babalik ka lang sa tatlong yon. Babalik ka lang naman sa tatlo para malaman mo kung what would be the result. So, these are the changes of the state. We have solid to liquid. What would be the process? We have melting, example, ice to water. Liquid to solid, process, freezing, water to ice. Liquid to gas, evaporation. We've already done that, the water vapor. Example, the chemicals or the substances in the periodic table. The bromine, right? Okay, bromine. Yan. Yung chemical symbol na yan. Okay, we have gas and liquid, condensation. So, from water vapor to water. We've already discussed that. Solid to gas, sublimation. This is actually a type of chemical reaction. So, dry ice to carbon dioxide gas. So, we have gas to solid, deposition, or frost. So, that is the changes of state. That is the possible changes of state of matter. Okay? So, that will be the end of our discussion for the kinetic molecular theory pertaining to liquid and solid. I hope you understand it. And please make your assignment. Okay? I will be waiting for your assignment tomorrow. Tomorrow, I will not be giving you an exact time. You can pass it even at 12 midnight tomorrow. Basta, tomorrow lang. hindi na pwede on Wednesday. Okay? So, good luck. God bless and good luck for your examination. If I cannot give you the pre-recorded video of intermolecular forces, I will be looking, or I will be focusing on the kinetic molecular theory pertaining to liquid and solid state of matter. Okay? So thank you very much. I hope you learn something today. And have a nice day. See you soon. Very soon.